draw this diagram, those who have not yet drawn it. Okay, see, we want to quantize a signal, that is, already we have studied the sampling theorem. Already I discussed regarding the sampling. Could you please tell me what is the meaning of sampling? Then we will focus to the quantization. Very good. Discretization in time signifies the sampling. Very good. Now, quantization is nothing, that is discretization in amplitudes. Signal means the signal should be obviously a continuous signal. According to the x-axis, we are denoting that is a time, and according to the y-axis, that is continuous signal as well as quantized signal will be generated. Continuous signal I am denoting by m of t, and the quantized signal I am denoting it by m cube of t. That is nothing which is an approximation of the original signal. That means I can write it m cube of t can be approximately written in terms of m of t, but not same, because quantization is staircase type waveform will be generated. So what are those things we will see subsequently. I am denoting. Please don't talk, try to understand. Any doubt you may ask at any time, no problem. Don't write anything. If you wish to draw, please draw it. Now the thing, see, my lower level and higher level amplitudes are mentioned, obviously in terms of voltage, that is VL and VH. VH is the higher level amplitude, VL is the lower level amplitudes. And I am denoting the spacing should be given by S, that is step size. Here I am mentioning L01, L02, L03, so on dotted up to L07. Those are the transition level. Parallelly, see on the right hand side, I have been mentioned M0, M1 up to M7. Are you getting me? What are those levels? See, these levels are generated at the midpoint of the step size. Am I clear? At the midpoint of the step size. So M0 to M7 is denoted as a respective quantization level. I will give you the time. Please try to understand. Don't write anything. Okay. Again, I will repeat. Try to understand what things are going on. Now I can write it that these differences, that is the same thing I can write, the step size is also to be called as a delta 0, delta 1 in terms of deltas, that is delta 1, delta 2, so on dotted, delta 3, delta 4, delta 5, delta 6. Obviously these are equispaced, delta 7. Now the thing is, the higher level of the amplitudes VH, follow, listen my words very carefully. Higher level of the amplitudes VH and the lower level amplitude VL is separated by the quantization level. What is my quantization level? Quantization level is my M0, M1, so on dotted, M7. What is my question? I am telling the separation between the quantization level and the lower limit and the higher limit of the voltages, that is, the distance is S by 2, because I am taking the quantization level from the midpoint of the step size. Are you getting me? Now, you may ask me, sir, why you are taking the 8 step sizes? Actually, this is 0 to 7 means 8 step sizes. So, what is step size, sir? Step size is nothing, that is VH minus VL by M. And for convenience and for illustration of this example, we are taking n is equal to 8. Already I have been mentioned n and relation between n and m. How many bits? When my n is 2, what is the bits? When my n is 4, what are the bits? And when my n is 8, what will be the number of bits? When my n is 8, how many bits will be available? What is the lower limit of the bits? So I can take 2 cube bits. That is the bit number will be 2 cube. That means 8. That means the lower limit should be started from here 0 0 0. That is 0 0 1, 0 1 0, 0 1 1 1 0 0 1 0. Please help me. Very good. Then 1 0. Clear? That's why for convenience we are using. I can insert n is equal to 16. Then it will be starting from 0 0 0 0 and it will be ended at 1 1 1. That means 0 to 15. Are you getting me? Now it is 0 to 8. Now the thing is, I will draw the continuous signal at first. This signal is denoted by m of t. Are you getting me? That is my continuous signal, my message signal, m of t stands. Now I will generate the staircase type waveform. How it will be? Now this staircase like nature is known as the m cube of t. This is known as the quantized version of the original signal. Are you getting me? This is the thing. So what things are going on? When my, please try to listen my words, then you will write. When my signal m of t, continuous signal m of t is lying at the region of delta 0. Are you getting me? When my signal m of t is lying at the region of delta 0, my quantized signal m cube of t maintains the constant level at m0. Are you getting? When my m of t is maintaining the region of delta 0, quantized version of the signal is maintaining the constant term at quantization level m0. Subsequently, when it is transferred from m0 to m1 with the help of the transition level n01, the staircase nature type waveform will lie at the m1, and in such a way quantized version of the signal will be generated. So at every instant of time, quantization error will be generated. That is very important for us, and we can measure the quantization error in such a way that is modulus of m of t minus m cube of t must be greater than equal to s by 2. That is the quantization error. At every instant of time we can measure it. Okay, so please write now. Please give the figure number, that is figure number 1, whatever else it may be. Figure number 1 illustrates the quantization of a signal, quantization of a continuous signal m of t, quantization of a continuous signal m of t whose excursion whose excursion is limited or is confined, between the excursion is confined between the VL and VH volts respectively. VL and VH volts respectively, full stop. full stop. The step size S, the step size S will be evaluated, the step size S will be evaluated based on this formula, that is, please write this formula. H minus BL by M. Okay? Where M is equal to 8, please write, where M is equal to 8, M is equal to 8 implies the number of allowable intervals, applies the number of allowable intervals, because see, I am making the 8 intervals now, M starting from delta 0 to delta 7, 8 intervals, so I am taking 8 say number of allowable intervals, full stop. Please write, at the midpoint of the step size S, at the midpoint of the step size S, we are denoting the quantization levels. At the midpoint of the step size S, we are denoting the quantization levels starting from M0, M1, so on dotted up to M7. Clear? Okay? Full stop. Now, after full stop, now when the continuous signal M of t, now when the continuous signal M of t, when the continuous signal M of t lying in the region delta 0, lying in the region delta 0, then the staircase type waveform, then the staircase type waveform, that is MQ of t, then the staircase, STAIR, staircase, because this waveform is staircase type nature, then the staircase type waveform, that is MQ of t, will maintain the constant level, will maintain the constant level at M0, will maintain the constant level at M0, full stop. Subsequently, when the signal M of t, subsequently when the signal M of t is at the region of delta 1, is at the region of delta 1, is at the region of delta 1, then the quantized signal MQ of t, then the quantized signal MQ of t, then the quantized signal MQ of t will maintain the constant level at M1, will maintain the constant level M1, and so on, and so on, full stop. The abrupt change, the abrupt change from one quantization level, the abrupt change from one quantization level to the another quantization level for a message signal, for a message signal M of t, for a message signal M of t will be made based on the transition level, based on the transition level, will be made based on the transition level, that is L01, L02, etc. Based on the transition level L01, L02, so on dotted up to L07. Okay, full stop. The extremes VL and VH, the extremes VL and VH, the extremes VL and VH are separated from the quantization level, are separated from the quantization level, are separated from the quantization level at a distance of s by 2, at a distance of s by 2. See, at the diagram I have been mentioned s by 2. Yes, that distance, similarly this distance also s by 2, equispaced. Okay, full stop. Also at every instant, also at every instant of time, 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 the quantization error, at every instant of time, the quantization error will be, please write, modulus m of t minus m cube of t, modulus m of t minus m cube of t less than equal to s by 2, less than equal to s by 2. Okay, modulus m of t minus m cube of t less than equal to s by 2. Clear? Para change. Since the quantized signal, since the quantized signal, since the quantized signal is an approximation of the original signal of m of t, since the quantized signal is an approximation of the original signal m of t, so please don't write. Could you please tell me how can I improve the effect? How can I improve the effect based on the diagram? Because see, I am using 8 number of intervals are available which starts from 0 terminating at 7, 0, 0, 0 to 1, 1, 1, 8 intervals. I need to improve the quantization technique. What should I do? Whether I will reduce the step size, listen my question, whether I will reduce the step size, whether I will increase the step size. Listen, if I am willing to reduce the step size means, what thing will happen? Reduce the step size means I can introduce more number of allowable intervals, and increasing the step size means I can reduce the allowable intervals. So please tell me which thing is best and prominent, by which quantization procedure can be improved. Don't tell me answer in hurry. Please go through the thing. Diagram is very prominent. Then please try to tell. So please write the improvement of the quantization process. The improvement of the quantization process can be made. The improvement of the quantization process can be made if we can reduce the step size, if we can reduce the step size, if we can reduce the step size, by which more number of allowable intervals, that means more number of allowable intervals can be introduced, full stop. Are you getting me what I mean to say? More number, because I am using m is equal to 8. Suppose I am using m is equal to 16. Better performance will be generated. Are you getting me? More number of allowable intervals, consecutively my step size will be going to reduce. That is my m. So now next heading is, can I erase this part? Okay. Next heading is quantization error or noise. Next heading is quantization error or noise. Please write the quantized signal. The quantized signal which is derived from the original signal, which is derived from the original signal, which is derived from the original signal can differ in a random manner, as there is certain error or noise is introduced, as there is certain certain error or noise is introduced, and this noise or error is to be known as a quantization error or noise, is known as a quantization error or noise, and is denoted by square bar square, averaging is equal to delta square by 12, where delta is the step size. Please write. This proof is not for you people, that is for easy student. Proof is very rigorous proof and it should be based on the probability distribution function. So I am not interested to derive that thing, but you should keep in your mind what is the formula for quantization error or noise. Delta is nothing, step size. Delta is the step size. Already I have mentioned the delta 0, delta 1 subsequently. All of you clear? Any doubt please ask. No. Next heading is quantizer. Quantizer, another important thing for quantization. See, in sampling, sample and hold circuit is needed for sampling. Similarly, for making quantization, quantizer circuit is to be needed. Are you getting me? Quantizer is nothing. When I am putting my continuous signal, my analog signal, subsequently it will, the ultimate or the output signal will be digital obviously, and the amplitude will be discretized nature. That's why it is known as the quantizer. So please write quantizer, a Q level quantizer. Please write a Q level quantizer, Q hyphen level. A Q hyphen level quantizer compares the discrete time input, discrete time input signal, which is denoted by x of NTS. Yes, this is compares the discrete time input signal x of NTS to a fixed digital level. Full stop. The discrete time input signal x of NTS, please write, the discrete time input signal x of NTS can be assigned to any of the fixed digital level, by which minimum distortion or error may occur. Full stop. This noise or error is known as a quantization noise. Full stop. The output of a quantizer generates A digital level signal. Output of a quantizer generates a digital level signal that is denoted by x cube of NES. Quantizer output signal will be denoted by x cube, x suffix cube. Q, where the suffix will come, you should keep in mind that is the quantized concept. Okay, n suffix cube quantized, x suffix cube, obviously this but it is in quantized nature. Here, now we will see what are the different types of quantizer. Heading is different types of quantizer. Please write it. Quantizer are mainly of two types. Draw the tree diagram. That is, quantizer of two types: uniform quantizer and non-uniform quantizer. Uniform another have two branches, that is mid-read, TREAD, and mid-rise. Non-uniform have no branches. Again, we will subsequently analyze all those things one by one. What is uniform quantizer, what is non-uniform quantizer, all those things.
So what is that mean?
Mid-read, TREAD, mid-read. Next one is mid-rise. Can I erase this part? Definition of uniform quantizer. Please write uniform quantizer colon hyphen. Uniform quantizer colon hyphen. When the step size remaining same, when the step size remaining same throughout the input signal, then it is known as a uniform quantizer. Non-uniform quantizer colon hyphen. When the step size varies, with respect to the input signal, then it is known as a non-uniform quantizer. Okay, now we will see the uniform quantizer. Already we have been mentioned mid-read and mid-rise. Mid-read, at first I will draw the diagram, then I will analyze. Mid-read, TREAD. silent please, try to understand. Mid-treat. It is a type of uniform or non-uniform quantizer? Uniform quantizer. One thing, step size are remaining fixed. Step size is not disturbed. Mid-treat means origin should lies at the middle position of the treat. Are you getting me? Origin should lies at the middle position of the treat. That's why it is known as the mid-treat. Mid-rise. Mid-rise. What is the difference between mid-treat and mid-rise? You can tell me by looking the diagram. Again I am repeating, both cases step sizes are remaining fixed in accordance with the input signal. That's why it is known as the uniform quantizer. Mid-treat, origin should lies at the middle point of the treat. Mid-rise means origin should lies at the middle point of the rising point. For a staircase like waveform, the waveform must be a staircase type, meeting middle point of the rising point. This is the rising characteristics for a staircase type nature. Yes or no? See, midpoint. That's why it is known as the mid-rise, and previous one it is known as the mid-treat. Any doubt, please ask. Okay, can I erase this diagram? Now we are switching to the non-uniform quantization. Silent please. Already according to the tree diagram of the quantizer, we have seen non-uniform quantizer does not have any class. Only one thing, that is non-uniform quantizer. Whereas quantizer denotes the two classes. One is mid-treat, another one is mid-rise. In case of non-uniform quantizer, don't write anything. In practice, it is not possible to construct a non-uniform quantizer. So best thing we can generate at first at the uniform quantizer, and correspondingly whatever the demerits have been occurred in case of non-uniform quantizer, that thing can be prevented. Are you getting me? So in case of non-uniform quantizer, one very known process is known as the compending. Have you heard this term? Compending. Compending. Just to listen my words. Compending is derived by two words. Compending. Compending is derived by two words. Compression, expansion. Okay. Listen my words. Very interesting thing and very easy. Compression and expansion. Compression will be had, obviously the transmitter and receiver system will be there. Compression will be had at the transmitter end, expansion will be had at the receiver end. Are you getting me? So, what device will make the compression? Compression will be done by the compressor, yes or no? Compressor, and expansion will be made by expander. And collectively compressor and expander is known as compender. Okay, this is the fundamental logic behind the compending of PCM. So please write. In practice, please write. In practice, non-uniform quantization can be made, non-uniform quantization can be made with the help of a compounding technique, with the help of a compounding technique. Full stop. The compounding term derived from the two words, that is compression, made by a compressor, and expansion made by an expander, okay, full stop. With the help of compounding technique, after full stop, with the help of compounding technique, the signal to quantization noise ratio, of a weak signal can be improved. Full stop. In practice, for non-uniform quantization, it is not possible to get a knowledge in advance about the digital signal level. Full stop. So for that reason, at the transmitter side, the weak signals will be amplified. And the strong signals will be attenuated. And the phenomena is known as compression. Full stop. Similarly, at the receiver side, the opposite thing should be followed. That is, strong signals will be amplified. and the weak signals will be attenuated. And the weak signals will be attenuated. A-T-T-E-N-U-A-T-E-D. Attenuated. And the phenomena is to be called as an expansion. Okay, full stop. Now we will draw the compressor characteristics. That is, phenomena is known as the expansion. Now we will draw the compressor characteristics. Characteristics. Right. Compounding characteristics. See, this is the compression characteristics coming. Again, compression is going on. Then expansion. Try to understand. Just like a eye. Yes or no? Eye type diagram. See. Have you studied the magnetic hysteresis? Huh? See. That is the one. What was the x-axis and y-axis? In case of magnetic hysteresis? This is not hysteresis. This is the compounding. Okay, here forward. I don't want. Please draw the diagram. See, compression is started, expansion is also going on in such a way. All of you listen, one dotted straight line is mentioned, yes or no? Dotted straight line, this is the dotted straight line. Please draw it quick. Right, the dotted, wait, the dotted straight line, again I need to it. This is the actual phenomena which occurs in case of non-uniform quantization. That means at first compressor will make the compression technique, then uniform quantizer will be used, that is as usually. Then after developing the respective output, that output will pass through the expander by which expansion phenomena will occur, and after that we can generate the actual output signal. That is the actual block diagram for the compacting technique. This is, please give the figure number, that is figure number something, that is you may give, this is 3, that is O, subsequently because all those things are 2A to B. Any doubt, please ask. Any doubt? This diagram, all of you taken? All of you have drawn this diagram? You have taken this diagram? This diagram.